Welcome back to the Atari ST Nostalgia GFA BASIC tour. In the previous videos we explored some really fancy ways to put some text on screen and we played around with it a little bit. In this video I want to go into a bit more detail into two commands that we actually were using in those videos, namely the GRAPHMODE command to see what actually the different graph modes are and how they work. And also I want to show you how the DEFTEXT command actually handles text sizes, because we were looking into text styles, that part we covered, but the sizes is not like a linear size model and it has some quirks. So I just want to show and tell about these two commands. It will not be heavy coding. I actually prepared some code to demonstrate the GRAPHMODE command. As you can see, I've created a loop and I will count value G from 1 to 4. And every time I will clear the screen, first I will go into graph mode 1 because I want to draw a box in the screen. And actually this is a black box on the left half of the screen, so the right half of the screen. So the left will be white background and the right one will be a black background, to see what the different modes, how they react to these backgrounds. And then I will actually set the graph mode to the value of the cycle we are in. So 1, 2, 3 or 4. There are only 4 graph modes. And I will print on the screen which graph mode we are in at the time. Then I will define the text as black text, bolded, but no, just a standard direction and size 32. And I will print the text, this is black text, on 4 locations in the screen. And actually these locations mean it is on the left side of the screen, so it is on the white background. I will then print the same text but on the right side of the screen, so it will be on the black background. And I will put it somewhere in the middle, so actually the text starts in the white background and then it runs into the black background to see if there's a difference that we can see. Then I will define the text as color 0, so I say I want white text, the rest I will keep the same. And then I will do the same trick but on the lower half of the screen and print the text, this is white text, so we can actually see the different ways the text will behave in the different graph modes. And then I will wait for an input from the keyboard, and when I've done that I will cycle to the next graphics mode. So as you can see, this is what we saw before. This is graph mode 1, and this means it creates a text box. I put black text and there's a solid white background. So on the left you can see it's black text on the white background. It's the same as the normal white, but on the right side this actually creates a white letterbox with the black text in it. And as you can see, the text also, it stays the same color. And on the lower part, the white text, you actually cannot read, because in all 3 cases it creates a white letterbox with a white text inside it. So on the right side you can see that the part where the text is in the black background, it actually creates a white letterbox, but you cannot read the text. So graph mode 2 is also something we already explored in the previous video. This is the one that actually makes the background transparent. So for the black text, the text will remain black, but actually the letterbox, the background of the text will be transparent, which means on the right side of the screen the black text will be black text and the black background will remain visible, so it's invisible. And you see in the white text, actually in the white side, yeah, it's white text on the white background, so it's still not visible, but on the right side you can see it displays the white text, but the background is actually the background from the box, not from the letterbox from the text. So you can see the text. Now the third mode, graph mode, is actually quite an interesting one. It's an XOR mode. So they say the background of the text, this letterbox thing, is XORed with the background, which means it compares each pixel with the corresponding pixel in the background. And if they are both the same, actually the pixel will become white. And if they are different, the pixel will become black. And so whatever the background, as you can see, you can always read it, and you can see even if the defined text is black, and during the drawing of the text actually the background color changes, it will just change the color of the text. So the black pixels of the text on the white background is different, so it will be black. The white background of the text on the white background is actually the same, so it will be white. And on the right side, yeah, the white background of the text with the black background is different, so it will be black. But the black pixels of the text on the black background are the same, so they actually will become white. So the text will, in the monochrome mode, yeah, the pixels will be either black or white. And you can see the effect is actually quite nice. But if you want your text to be a very specific color, then this doesn't work. So Graph Mode 3 is actually quite interesting, and another one that's quite interesting is Graph Mode 4, which they call the reverse transparent mode. And what this does is actually it creates this text box. So as you can see in the left top, it originally was a black text with a white background, and it reverses those. So it says no, everything that was background is now actually the black pixel that I'm going to draw, and what was the text is actually now the background. And after it did that, it actually applies Graph Mode 2 to this. So what you see is this, the background became black, and that's actually the pixels it's drawing, and the texts, they are sort of transparent holes in this letterbox. So on the left, with the black text, that is now a transparent hole. You can see that actually the white background is shining through, which also means on the right side, it cannot be seen because you have these black pixels that are drawn on black, so they are invisible. But the holes, the text that are now transparent holes, are actually also not visible because the black background just fills it in with black. You can see the black background after the text, behind the text. And in the white one, you can see the same happening. So the white text becomes a hole, and the background becomes the white letterbox. So the letterbox, the text background is actually the pixels it's going to draw. Defined by the color in your DEFTEXT, which is white. So you can see in the right bottom it draws these white pixels, and in these white pixels there's actually transparent holes in the shape of the text, and because the background is black, you see it as a black text with a white background. So yeah, it's quite interesting. This is something nice to experiment with. I think this little piece of code actually shows you what it does. It can help you determine what kind of graph mode you actually want to use when you use the text command and DEFTEXT, because yeah, sometimes it can get quite tricky. So it's nice to be able to go back to, and yeah, it just loops. I will just stop the code. But I think yeah, this code is just a nice way of determining like which one was it again that I wanted to try to go back to. Learn yourself how it actually works, because it can be quite tricky when you're using init code, I guess. So that's why I did this little show and tell. Now the other command I wanted to go into a little more detail is actually the DEFTEXT. So also for that I created a little bit of code to this time not cycle through the different styles. So I will keep the style the same, basically normal. And also just black text. I will not do anything fancy with graph modes, because the only thing I want to do is actually go 4 times through a cycle of 8. So 4 times 8 is 32, so I can get all the values for the size. And in each cycle I will actually create a size which is the size of I. So I start at number 1 plus the screen times 8. So if I'm at screen number 1, it means the size becomes 9, and then 10, 11, 12, etc., etc. And of course I have to start at the start line, so I will start at pixel number 40 to don't have the text like right at the top of the screen. And for each cycle I will actually say, look, you have the line, but you have to increase this number. So take your original number and actually add the size of the text that you determined from this counter, and then add another 10 pixels to put some white space between the lines. And then yeah, I will print actually at the middle of the screen, and at the second row I will actually print the size that we are showing now. And so the last printed text was the size that it shows on the top of the screen. I will define the text with the same size, and then 80 pixels from the left, and on the height of line, which is determined here, I will just say this is how the text looks now, and wait for a key press for the next line to print. And if it did 8 lines, it will actually clear the screen and make the screen number 1 higher, so it will go into the next group of 8. And for some reason I felt it necessary to draw a box around this text on the top of the screen. It was just, I don't know, I felt like it, so I did it. But let's see how the text sizes look, because actually it's not entirely as you expected. You would expect it to be some sort of linear increase in size, and that's not really the case. So as you can see, the size is 1, which means the text is 1 pixel high, and that means yeah, it's unreadable. And for size 2, it's actually exactly the same. You cannot read the text, so these sizes are useless. And size 3 is almost readable, but actually size 4 is the first one that you can actually read. And this is also the 6x6 system font. So this is the text that is used in icons and such in GEM, for instance. It's size 4. So if you want to use that text, use size number 4. Size number 5 is actually a lot more difficult to read. And size 6 is actually the 8x8 system font. So if you also go to text 8 mode in your editor, this is the text it's using. Size 7, it will just sort of magnify the system font and make it a bit bigger. And yeah, we came to the next screen because we had 8. So now we are at size 9, size 10, size 11, size 12. So it's just getting bigger and bigger. And then suddenly we are at size 13 and the text is again, it's a lot smaller again. So basically up to size 12, it's just magnifying the 8x8 system font. Size 13 is actually the 8x16 system font. So this is the basic font that it uses when you use the normal print command. And it's also the font that it uses like in the editor in text 16 mode. That's size 13 is this standard text. And after that, from 14, 15, it will just magnify this standard system font. So it will make the text bigger again. But now based on this 8x system font instead of 8x8. And something interesting happens when we are now at 24. So when I press again, it will actually clear the screen and make a new one. And the size will be 25. Now the size is 26, which is getting pretty big. And interestingly enough, 27, 28, 29, 30, 31 and 32, they are all the same size. This was probably not supposed to happen, but there is actually, there's actually a bug. I don't exactly know if it's a bug in GFA BASIC or it's just a bug in actually the Atari machine code or in the instruction sets itself. But yeah, starting from size 26, actually all the other ones above that are actually the same size. So you cannot get higher than size 26. I still sometimes when I say I want a bigger size, I don't want to remember if it was 26 or 25, so I just put 32. But you can see the first few are really, really unusable, but the standard ones you use for icons is actually size 4, which is good to know. If you want to use the 8x8 system font, it's actually size 6, and you can magnify that one. This one doesn't look really nice, to be honest. So I prefer actually to use size 13 and up, because this is the standard system font that you can also sort of magnify. The graphics are created based on that font and the magnification factor, and it doesn't always look that nice. So I prefer, if you want something big, just use size 26. If you want to have big text, the other ones just don't look as good. I guess this is because this is twice the height and twice the width of the system font. So the pixel, it's 2 pixels instead of 1 compared to the system font. So the sizes to use in standard code are actually size 4, size 6, size 13, and size 26. And the rest, you can use them, but they're either unreadable or they look kind of ugly. But yeah, this was just also some piece of code. If you want to see what they all look like, just go through the cycles and note the size for yourself, and determine the one you want to use, and then use that one in your code. This is basically all I wanted to tell in this video. This was just a quick extra recap of 2 commands to see show and tell what the outputs actually mean. In the next video, we will be looking at something else. I don't know exactly what. I still have to decide. But by ending this one, I hope you enjoyed watching it, and I will hope to see you next time.